Sam with Nexus Workshop, and we are in here looking at the prop controller, and we're looking through all the different pages of the configuration. This page is going to be one of probably the most meaningful. This is the behavior page. This is the page where we make it do things. So far, we have decided what we have connected up. We've defined a couple things around there, like our level inputs, or we've defined some states and some variables and things we're going to commonly reuse. But this is where the meat and potatoes of take the thing and make it do a thing actually happens. There's a couple different ways to do that. On the top half here, I have logic rules, action triggers, and operator controls. Those are all inputs. Logic rules is just inputs, and the output is just it fires. The logic rule goes. Action triggers is Logic rules is a lot of inputs conditionally stacked in different ways, and then it fires. Action triggers is a single thing happens, and now I can trigger a whole output sequence. Operator controls is a single thing happens, but it's driven from the operator page, and a chain of things can happen. Input sequences are like button codes. This happens in order, or this happens in time, but those are ways that players interact. And an output sequence is just the output side of that, but it's actually a little bit heavier. So it's like an action trigger where I have an input goes into a bunch of outputs, but the output sequence has more controlled timing and the ability to do like repeats or vamps or things like that. Think of it more towards where you're going to start doing media sequences and pieces that you'll reuse. So I might build out an output sequence and then have that triggered by an action trigger or a logic rule. Collections is another type of player game that we can do that we'll talk a little bit more about. And the live monitor is just a way for you to see what's actually happening right now to help you debug a little bit while you're kind of playing around with your puzzle and checking your behaviors, staying on this page without having to go anywhere else. Let's actually click into them though. So logic rules. In here, I'm able to create logic rules. Here I have one, and I have called it should solve. That's what I named it. It is of the type match all. I can have it match all, which is an and. It's this, all of these conditions have to be true at the same time. I can do any, which is when any of these conditions are true, then it goes. I can do none, which is all of these conditions have to be false. It is a opposite of all. And I can do the first match, which actually acts more like a router. Most of these things that you're building are going to be alls and any's. And it'll typically be alls feeding into any's. So I might create a logic rule where I say all these things have to be true, and another one where I say all these things have to be true, and then I can have an any rule where I say when either of those two rules happens, then it goes. This can get crazy. You can really stack into this in different ways. Like I already showed, you can be going logic rule feeding into a logic rule or feeding an action trigger or whatnot, but that's the basis of it. Refire every says, does it just go once until it gets released? Or as long as it's held true, does it keep pinging? And so if you were to put a refire says every 500 milliseconds, then as long as it was true, every half a second, it would fire again. There are applications for that. In general, though, you're going to want to put it at 0, which is going to say never refire. It stays until it becomes false or unmatched, and then it goes again the next time it becomes matched. Here I have my conditions. So this one has 2 conditions that I've put onto it. This one is of the type state. So it says, hey, when the state equals armed. When we're in state armed, and, because it's an all, when this variable, this one, equals false. I have a bunch of different things that I can use for my inputs. This is one of those dynamic fields that's going to populate based on other things I have. So if I don't have a variable, I won't be able to choose variables here. Make sure you define your connections and define all your definitions before you come in and do your behaviors, because you won't be able to build a behavior if you don't have the source of it. I can add a new condition. So actually, yeah, here I'll add a condition, and I can come in here, I can say input solve button, when the solve button is pressed or when it's released. Or I could say when it's not pressed. If I don't use that one, if I use a different one, like if I use analog on my puzzle knob, you'll notice that all these fields are dynamically populating based off what I've selected. It chooses what the available options are. But a digital button can only have yes or no. So I only had does it equal or does it not equal. In here, I can say equals, not equals, greater than. I can say it's between this range, and I can start to do a little bit more. I also have in here if you remember right, my level inputs where I built out this thing called floating. So I can do some cool stuff there. You're going to have to play around with this to see all the different things it can do and what you can do very specific to your puzzle. But logic rules is how I would take a very complex input side and then it fires. Now again, you notice that it doesn't do anything here. The end up outcome of all of this is that should solve fires. I need to make it do something. I'm going to do that either with an output sequence or with an action trigger. Here in action triggers, I've got a couple action triggers that I've built out so far. This one's called override. It has a single input. It's called override. It's using the type input. This button's the one it's using, and it's when it's pressed. So when the solve button is pressed, go. It can have its own debounce, which I've talked about also, that like I can specify the debounces, so I can say, hey, this one needs to be longer, or I can put it on the default, and it tells me right here, well, because of global, that's 40. That's what the global default is. And then here are my allowed states. It's only allowed to happen while we're armed. I could change it to any, which would let it happen no matter what. But right now I said, no, the override only happens while it's armed. Actually, that's not a good idea. Maybe because it's an override, it should happen in any. So now it can happen in any state. Versus the actual puzzle solve can only happen when we're armed. You can also check multiple of them. One thing that's really cool is on actions that are triggered by states. So like this one here called reset light, its trigger type is a state. When we enter the off state, so when state off is entered, on enter, I could add a debounce, then do this. But because I have it checked for armed, this will only actually happen if we go from armed to off. That's a specific and special behavior of the on enter. Normally I would take something like this and I would also make it any. I say, look, anytime we go to off, I want to turn my light off. Now let's talk about the output side of an action trigger. So up here we have this action trigger. A new thing that we have is this little play button. We haven't seen that a whole lot yet. That is my ability to test. So I can click that and it just fires the thing. And it fires the entire stack. If I click this one, it fires the whole action trigger as if this had just become true. So I can use that to test my stuff. Down here, I see my actual steps. So this one looks like 2 steps right now. I've got this one and this one. This one is is a pixel lighting type step. So here's all the different things that it could be. And again, these are dynamic. So these are I only have pixel lighting because I have a pixel strip added. But in there, I'm able to do all the pixel strip things. The pixel lighting effect is one of my biggest steps. It's got a whole lot of different parameters I can drive. A lot of power there. If I want to just fire this step, I can do that right here. The other thing that is global to all steps, I have my type and then I have all my parameters, but this delay. The delay is going to be since that action trigger fired, how long until I actually fire this? 0 means do it immediately. If I were to say, 1500 milliseconds, then it would wait 1.5 seconds, and then it would fire that. These steps don't have any order to them. They all fire theoretically at the same time, or they all start their delays at the same time. They don't chain off of each other. So if I put a delay on this top one, that second one would still be firing at 0. It doesn't wait for the top one before it goes. It is not a sequence like that. Here I can add more steps, and I can just keep adding and chaining steps. Important to note in here is that some of my things I can do is I can do an action trigger as an output. So I can take an action trigger and have it fire an action trigger. What that lets me do is build things like, say, I want to have, I've got my pirate chest, and I want to have a sequence that I can build on an action trigger that's called open, that undoes the latch and turns the smoke on or turns the lights on or whatever. I can do all that and have that whole sequence. And then when they solve the puzzle, I can run the open sequence. That now lets me run the open sequence from my operator page independently of the solve. So I can start to kind of like build these blocks that I later reuse with other blocks so that I'm not constantly rebuilding behaviors over and over again. It also means that when I later decide like, hey, whenever they open it, I need to add this new step or I need to do this thing, I just change it that one time because everything else is actually just referencing that. And that's just gonna be good practice. Depending on how heavy you get with your stuff, you'll need to think about it more or less. But that's where you're gonna really get a lot of power out of a system like this. Operator controls. This is going to be very similar to action triggers, except like the whole output side is exactly the same, but the input side is right here. So I'm able to give it a thing. I'm going to call this, let's call this highlight. It's going to be a button, and I'm going to make it do pixel lighting. It's going to take that pin, and it's going to set it white. That's fine. Here I'm able to choose the type. Is it a button? Is it a toggle? Is it a drop down? Is it a text box? And these are literally things that are going to show up on the operator page for the operator to interact with. One of my favorite things to do is to create a drop down and just give it an actions, just like things you can do. Instead of having individual buttons for it, just give them a drop down with all the things in it. And it can be a lot of fun. Here I can change the style. This is going to be kind of generally color styling it. I can give it a confirmation. If I put something here, then that means it's going to ask them, hey, are you sure you want to do that? So if I wanted to say, like, maybe I give an override button that triggers that. So let's change it to that. So I'm going to call this override. It's going to be a button. Its output is going to be that action trigger called override. And I actually don't need to do this because I can just trigger that on the operator page. Let's say I wanted to. Down here, I'm getting a preview of what it looks like. And that is actually running that test. And then up here, I could give a message. So now when I fire it, it doesn't do it on this page, but when I do that from the main page, it would actually bring that pop-up up and say, hey, give this message first, make them confirm it before we go. Feedback, I can have it be auto, which means like if I were to tie a button to a state, for instance, then or maybe I tie a button to a variable and I say set this variable to that value. Whenever that variable is that value, then it would be lit up because it's there, it's already done. But that's what if I'm on auto. I could also tie my feedback to other things. So I could tie it to another input. And here's where I could define out what input do I want and what value do I need to have or something like that. But I can drive that off things. So maybe I say like, hey, there's a game where they need to do this 3 times. And I could make my operator button feedback light up when they've done it 3 times because that variable went to 3. And then that's when I click go. Something like that. Input sequences are for the actual players. There are 2 different types. There's the ordered sequence and there's the time sequence. The ordered sequence is your traditional button code. Hit them in order. The time sequence is more like a Morse code type thing. When I come into my button code, my ordered sequence, I can give it a name. I can give it a timeout. And that works independent or in partnership, I guess, with this mode. In continuous mode, if I build out a code that has 4 slots, then in continuous mode, it's going to keep doing those 4 slots. There is no fail, per se. It's waiting for you to have all 4 of those slots have the thing in order, but it's going to Pac-Man rules it. So after the 4th one, the next time I do one, it's just going to bump everything down and keep filling it in. Timeout says, in continuous mode, says once there hasn't been a button push in this long, go ahead and erase it. That way they don't come back and accidentally just hit the one button they needed and it works. You want that to be long enough so that it's not erasing things on your players when they're actually working on it, but you also don't want them to have forgotten about something and come back and accidentally trigger it. I can choose only the states that the sequence is allowed to move forward in. And my other modes are instant fail, which is the moment they hit a wrong button, it triggers a failure and it resets it and goes back, or allow misfires. Allow misfires, because this doesn't have to just be a button game. This could be, let's say I've got my knob here, or my fader, and I say my puzzle is I have to go from slot 1 to slot 5 and back to slot 4. Allow misfires would say you need to see 1, 5, 4 within that timeout, but I don't care what else you see. Because to get from 1 to 5, I have to go through 2, 3, and 4. So I couldn't not do it. So that's where allow misfires are going to allow you to build a puzzle like that. Whenever you're doing an order sequence, you're going to do it with mappings. So I'm going to take these mappings. I'm going to say I add a mapping where it's going to say solve button is active. And you see that little, if you're watching my little pop-up up there, that is something I'm working out right now that has to do with a safety thing on persistence. And get it solved in a second. But so right now, if I take this, when they push the solve button, then I'm going to call that 1. And then I would take this out, and this would be a different button. And I would say that would be 2, and this one would be 3. And then I can come and say my code is 1, 2, 3. Or I can also, I can write it if I want with commas, which can be a little easier to read. It'll parse it either way, but it's using these tokens that I gave here. These tokens can also be things, like if I make this red and green and blue, then I can come in here and say that my code is green, green, red, blue. And that's my code. And now that's 4 long. I'm in continuous mode, so it's going to be looking for green, then red, then blue to be pressed in that order. And if we wait 30 seconds without anything being pressed, it'll erase the buffer. On the operator page, it's going to show the sequence and everything about it. Everything is happening. It's really cool. The other type of sequence I can build is this time sequence. That one is going to let me, like I said, do Morse code or do timings, knock puzzles, that sort of thing. Same sort of thing, I can choose what states it's in. I can choose our timeout and our tolerance. That tolerance is on the timing. Absolute timing is basically tempo. Do I care about tempo? So if we think of, a knock puzzle, I do shave and a haircut. Shave and a haircut could be very fast. Shave and a haircut could be very slow. If I care about absolute timing, then I'm saying it should be fast. This is the timing it needs to be at. If I uncheck that, then I'm looking for relative timing, which says for shave and a haircut, I don't care what tempo it's at, but I care the relative delays between each of these notes. So these are all eighth notes and these are quarter notes or these 16th notes, that sort of thing. If you think about it musically, you don't have to, and you don't need to, because when you come in here, I'm going to build up my steps. So shave and hair cut, and I did it all on this one button. And then you can come in here, you can hit learn, and when you do that, it's looking for this, and you would then press the button in your orders. It would record those timings. You hit stop, and then all those timings update here. And it's looking for you to do that on the actual thing. That way it can see what it is. Because again, if it's like a piezo or something like that, it wants this auto calibrate. It's using that to say like, what is a go, what is a trigger, and then those timings, it's just learning off of it. But you can kind of really quickly build up puzzles like that right here, and then play with that tolerance. Are they solving it too easily? Are they solving it too hard? Whatnot. Output sequences, like I said, is where I'm going to build my chains of events, my shows kind of thing. If I come in here, I build an output sequence, like everything else, I give it a name. I can change a queue policy. So that says, hey, if you're playing and something else triggers you, what do? Do you go back to the beginning? Do you ignore it? Do you queue it up and say, I'll play that after I finish this one? Or do you interrupt it? Here I can add steps, and this step has the same sort of action sequence that the action triggers do. So I can choose what it is, what it's targeting, and then choose all the things about it. And then I have this hold. Now this is where it starts to get different. In action triggers, our delays did not care about each other. They were all, the action trigger fires, and then each step waits its delay and then goes. Here, they are sequencing. They are going in order, and they are holding after each one. So this one fires and then waits 250 milliseconds before the next one fires. You can think of this a little bit more like if I were to have like a lightning storm where lightning flashes, strobe light, and then the strobes fire in this order, and that's what my players are looking for a puzzle or something like that. This is where I build that whole sequence, and that way I can trigger it up quickly and fire it and give myself a button on the dashboard to trigger it whenever I want and have it re-trigger every 5 minutes from an action trigger that is like redoing this, that sort of thing. You can also learn timing and step timing here. So if I need that lightning flash to do a certain timing or thing, I can learn the timing and I can click step timing to record that. And then you have this test button where it's just going to play your whole thing. But you can choose how many times you want it to play. So do I want it to just play once? Do I want it to play 10 times? If you put 0 here, it will loop indefinitely. And then this whole output sequence, when you fire it, you can actually do that same thing. You can tell the output sequence, fire 3 times and then stop. You also have a thing called devamp that you can do to an output sequence. That is a thing you can do with a trigger or another action sequence or anything that can do things. And that devamp is going to say, finish your current run, but don't keep repeating. And so those can be really powerful together. Collections, I'm not going to go into too much detail right now because I'm still working on this one a little bit. What I'm going to say about collections is its concept is things where you're counting. The good example of this is, let's say I have 4 RFID readers, and my puzzle is that I need to have these 4 things collected on it, but I don't care which one goes on which. So that's not as easy to solve as otherwise. Like usually it'd be very easy to say like, yes, I need to get those 4 things and put them on the 4 places. But if I don't care, I just say I've got 4 columns, whichever one happens, when you put the red one somewhere, it glows red. When you put the green one somewhere, it glows green, whichever one it's on. And when you have all 4 of them, you're done. Collection is how I'm going to do that. I'm going to build each of those triggers independently that says like, hey, maybe I would take something that says, hey, the red one got placed, set a variable, red is placed. And then an action trigger that says, when red is placed, turn on these lights. And then now I've got that feedback side done. And then over here in the collection, I'm able to say, you need to have these 4 things collected. And it's able to look through that and give me that count constantly. So maybe I could have like a meter of LEDs that's showing how far progress are, how many do they have collected. And it is collecting them no matter what order they do them in, no matter which one they put them on, any of those things. But it's just a different type of game. Live monitor, nothing to really talk about here. We talked about it on the operator page, but you can choose what you want to show up on the monitor in the log. You can download it. You can send it, which will actually just send it up to me so I can help look at it. If you're having issues with something, you can clear it, pause it, and you can look at all the stuff. And that is the beast of the behavior tab. We got 1 tab left. We're going to go about lighting. See you in a second.